Why path dependency blocks sustainable systemic transition? First, we need to understand why sustainable systemic transition is relevant for societies and people. Secondly, it is relevant to define system boundaries. Thirdly, a systemic transition is defined, followed by the definition of the sustainable transition. Next question reviews some key barriers of sustainable transition. Sixth theme will discuss on the path dependency. The last part looks for solutions for solving path dependency. The need for the sustainable systemic transition can be summarized through three main reasons. Limited planetary resources should be shared equally among the increasing number of people. The safe boundary level has been exceeded already in climate change, biodiversity loss, and biogeochemical flows. People have moral right for equal life. United Nations has defined the Millennium Development Goals, which concretize the basic elements for good life. Third element is a combination of the first two reasons, the concept of sustainability and sustainable development. In other words, societies and economies' role in sustainable development. The traditional, three-dimensional sustainability model is based on equal importance of environmental, social, and economic sustainability. This is called as the definition of weak sustainability. The idea of weak sustainability is that human capital can substitute natural capital. According to this approach, the future technologies will be capable to solve the food production if we destroy all arable land today. The future is unknown. Consequently, the approach of strong sustainability considers that natural capital is not only a stock of resources, but a set of complex systems consisting of evolving biotic and abiotic elements producing number of ecological services that may not be possible to replace by future technologies. Sustainable societies and economies should adjust their operations at the safe operation level. Systemic transition takes place within an open or closed system. A closed system is a unit that has no interaction with other systems and surroundings, for example a closed bottle. Majority of the systems are open in one way or another. An open system is a unit that interacts with its surrounding environment. It can be a factory, society, town, food system, energy system, water system, mobility system, and so on. The concept of systemic transition emerged in various scientific communities as a novel way to address large-scale societal change and sustainability in the 1990s. Systemic transition refers to the change from one system or regime to a more efficient system through technological, economic, social, environmental, or any other innovation. Transition and adaptation is needed comprehensively in the related policies, infrastructures, technologies, business models, markets, consumption habits, and cultures in order to reach the new system. A transition period is around 20 to 30 years. Concrete examples are the development from sailing ships to cargo ships, from cable-based communication to mobile phones, and the agricultural technologies from horse to tractors. Sustainability transition is defined as a radical transformation towards a sustainable society. The socio-technological context means that the sustainability transition requires the adoption of sustainable technologies, economies, policies, practices, services, and behavior. Policy, business, and societal actors must be active in promoting the change. One example of a socio-technological, sustainable transition process is the telecommunication, the change from the cable-based communication to the mobile system. The process has been a financial success story for the mobile phone companies and operators. The strategical choices promoted sustainable transition in that the companies understood the potential market for cheap phone models accessible for a large number of people globally. The systemic transition promoted the equal communication in lower-income countries and regions. It has promoted even the freedom of speech. Regardless of some success stories, the systemic transition is a challenging process. Various elements of socio-technological barriers block the development. Several organizational, institutional, educational, market, and policy mechanisms are built for today's solutions. Existing business models can be safe and financially profitable. Dominating industries are based on the current technologies. In this context, the change towards a new operation model can be perceived as a risk. Individual actors may be hesitant to change from the current practices to some unknown systems. The current system can be comfortable, financially attractive, easy, guaranteeing nice lifestyle. Path dependency refers to the permanent system. The system cannot be changed easily due to historical reasons. Technological choices that were made in the past define the current system, and how it is applied, and can be developed further. The phenomenon stabilizes the system, leaving limited space for new innovations and radical thinking in the society. The system is resistant to change because of financial reasons or existing policy mechanisms. For example, industries may prefer the existing technologies if the entire production process, from raw material acquisition up to the market, is based on capital-intensive, existing solutions. One example on the path dependency is the development of electric vehicles. First electric vehicles were built in the mid-1850s. The further development of the electric vehicles did not fly because of high production and operational costs, low top speed, and short range of battery electric vehicles. The rise of the new oil economy blocked the further development of electric vehicles in the beginning of the 20th century. Abundant oil resources and new technological innovations lead to the development of internal combustion engine vehicles that were cheaper and faster than the electric vehicles. The use of electric vehicles continued in freight equipment and public transport, especially rail vehicles. The institutional framework, including policies, infrastructure, technological development, and markets, was based on oil economy throughout the 20th century. The oil economy created path dependency, which limited the development of alternative technologies for mobility. The raising environmental concern and visibility of the climate change opened the doors for electric vehicles in the late 20th century. However, existing institutional structures favor still intensively the traditional, off-dependent mobility solutions, even though the systemic transition is going on. Solving of path dependency is a challenging and long process, but like the electric vehicle example showed, changing operation environment can create pressure to change the established operation models. The change needs some external, landscape-level initiative pressure, like rising of the oil economy or increasing public concern of the climate change. The radical innovations will develop to generally acceptable operational models. The solving of path dependencies require contribution from policy, business, and societal actors. This requires rebuilding of institutional mechanisms, allocation of research, and innovation funding for new technologies and operational models. Social acceptability of new ways to behave and operate need to be boosted and supported by education and policy instruments. The future is unknown, but current societies operate at the risky level of planetary boundaries. The sustainable systemic transition is of utmost importance already today.